Hello, everyone. My name is Lloyd Portes. I'm doing computer science. Sorry. I'm doing computer science. My course ID is BSHCSD4, and I welcome you to what I've done so far for my project named Subtitleizer. So, in the project overview, the project is supposed to take video and take it apart and then put it back together with subtitles. The project was originally intended for people who have videos they find online and would like to have subtitles, or for people who would like to reach a wider audience for what topic they are covering. So for examples like teachers. The problem addresses is for people who want to have the video with subtitles, but they do not want to place it themselves. The closest thing right now is YouTube's captured captions. This allows you to have subtitles, but only if you watch it from the video from YouTube itself. And yeah, but the closest thing is basically YouTube captured caption. The difference with this one is my intended goal was for the user to be able to to input a video, have an input language, output language, then export the video, and then they should be able to play it. That was the main goal all along. Yeah, so technologies. The technologies I've used is basically Visual Studio's FFmpeg, GLFW, /OpenGL, and Google API. Well, supposedly wanted to use at the very least. Visual Studios. I used Visual Studios for coding my project in the language of C. I used the libraries from FFmpeg and GLFW. The reason why I used Visual Studios was because I was able to connect the libraries and be able to use their files. So I would open up the library and then be able to use their header files for both FFmpeg and GLFW. This was a bit complicated in Visual Studios, but it gave me the customization that I haven't seen in other IDEs, and this helped me a lot for it. FFmpeg is a very strong library in the sense where the user is able to take a video and manipulate it however they want. In my case, I wanted to put a subtitles on top of the video, and I'll explain that a bit more later on. And GLFW/OpenGL is basically be able to render video in real time. Yeah, so I downloaded GLFW from the repos from GitHub, same with FFmpeg, and OpenGL is GLFW is the libraries, and the OpenGL is the actual software itself where it allows you to render. GLFW is just telling OpenGL how to do it. And Google API, like I said before, this is the part where I wanted to use Google's API transcription, where it would be able to take the audio from the video, transcribe it, make it into an SRT file, which is the subtitles, and then that file would then be placed on top of the video. So testing, the unit testing was performed covering all unit code units with a variety of tests. Integration testing was performed to ensure like everything between the components, the functions, and the reliability was always working, it was consistent. And then the end user was, which I did myself, was making sure it was nice, easy, and understandable for other people using it. This was performed, all the testing was performed by me. So system demonstration. So this is where I was supposed to show, this is where I'm going to show my GUI, but the GUI does not work with the actual script itself so far. So let me show you that now. Welcome back. So this is where I'll be showing you my GUI. This is basically this is how it works essentially. So when the user, this is how it's supposed to work. So when the user initially opens up the program, what it's supposed to do is, I'll show here, once you press the search file, the user would be able to pick a video out. I've ensured that only video extensions would be usable. So for example, for this one, so I'll just show you that it's able to take all. And then but for the videos, it should only be able to take this. And then it would be inputted into here. So that's what it does. And then once the Google API, the plan was for me to take the API and be able to put the languages here. So this will be automatically filled up with Google's given languages, and then also the output languages, and then it'll export. And then this is the loading bar that should occur. So now let me go through the code that's actually doing the grunt work for processing a video. So this is where my script basically works. So we have 3 files that we work with here. This is where it'll get the video, manipulate the video, and then have a small output. So my video right now, as of now, is only able to take an input and then show the output. Currently there's no audio and there's no subtitles on top. Let me show you how it's running. So this is my video from my project proposal. I'm showing it here. It is running. And then once I exit out, so let me go back to that. This works when the cursor is on top and you're not moving the cursor, but once you start moving the cursor around, it starts having a hard time decoding. So it's waiting for frames to catch up. It's currently playing in real time, and I'll explain the process of how this works, and also explain this after explain the code, because this will be tied in. So this file is basically the backbone of my project, and I'll be explaining it to you here now. So what's happening here is I have a structure called video reader open, and then it contains the variables that it needs to be called. So, and then afterwards, we're going through the, I don't know if you can see that clearly. Let me just zoom in there. What's happening here is I'm calling the variables and then saying I want to use these variables here. And then these variables that I'm putting here that are naming, this is only going to be used in this structure and nowhere else. Okay, so, and then the next bit is basically me calling AV format context and then allocating it for memory. And if it can't allocate the memory, it prints out a response. And then the next code is for opening my file. In this case, if you wanted, this will open the video, and then we're going to get the context of the video, the name, and then if you wanted to edit it, it'll be used here if you want to manipulate it for processing. And then if it couldn't be opened, we'll get another response saying no, and then AV log error, which basically outputs an error from FFmpeg themselves saying here's the error why it couldn't be opened, and then our response will be could not be opened. And then the next bit is the for loop for the video. So what's happening here is the video is being checked for the streams it has. So what that basically means is to every video, as I've said earlier, there is at least 2 streams, which is the audio and video. What's happening in this section for the for loop basically is in the AV format context, I'm looking for streams. Every time it finds a stream, you add it. And then if it doesn't find a codec, it'll say, okay, let's keep looking for a codec. And if it finds a video stream, what it'll do is that it'll say the codec type is a video, and then it'll say the video stream index is I, so meaning that there is something there. And then we're going to be committing the width, the height, and then the time base. So the width and the height is basically for the video that's going to be made, and then the time base is going to be the timestamps for the frames that we're going to be using later on. And this is also looking for a audio stream. But if there is no video found, so if the video stream index is less than 0, or in this case -1, we say there's no video stream found. The same thing is done for the audio stream. And then the next bit is we are setting up the decoder. We're trying to figure it out what it is. So these are my checks to say, hey, do you have, so saying basically hey to the video saying, can we find this? And if it doesn't find the AV codec context, the initialization is failed. And then, sorry, if it can't create the AV codec context, the codec context initialization is failed. And then the next bit is checking for the codec parameters conversion. Then the next bit is to open the codec itself. If none of these work, the project itself gives it an output to the user saying this does not work. And then once we find, so this is basically opening the codec. If we find a codec, it continues on. If not, we're going to print out an error saying it doesn't work, and then it closes the program and outputs something for the command console the user gets. And then this is for the AV frame. If it's allocating the memory for the AV frame. If it doesn't, there's an error. The same thing for the packets. This checks for the packets and frames. So again, we're calling our members. And then what it's basically doing here is if we are able to read a frame, we are basically saying continue for looking at the packets. We're opening them up, reading it, which is here. If there's a lot of packets, we keep reading, and then what it does here is that it closes that packet so we don't have a memory leak. If we do not have this, what basically happens is that it'll be opened until the program is closed, and if your video is very long, this will eat up your memory, and it'll slow down your PC, make your performance even worse while decoding while trying to get the packets for the video. And then what it's doing here is it's decoding the packet, and then if it fails, we have a error. And then what's doing here is if it receives a packet, we're going to be checking it for AV codec context in the AV frame, which is basically saying, hey, I received the frame, it has this. And then we're sending that later on to, we're sending that onto our renderer itself. And then again here, once everything is completely done, we're gonna unref the packets. I forgot to mention here that the reason why it unrefs the packets here is because if it fails, it closes everything down. Here, it closes the packet if it doesn't find a packet. So what it's basically doing, it's continuously checking the packets until it finds something. But every time we finish one cycle, it will close itself. And then once that's done, we go on to setting up the output for our command line console. So in the command line console, I have given out the index of the current frame, which is the first one here, the timestamp of the presentation frame, the decoding timestamp, and this in the fourth one basically indicates if the frame is a keyframe or not. The next one is representing the number of the frame, and then the display picture number of the frame. And then this is where we set up our SWS scaler. So this is a part of FFmpeg, basically saying this is the height, this is the width. The AVPix format RGB0 is the way the color is being used. If we're using RGB0, we want the simple colors. It's going to be fast rendering. It's going to be fast color pictures, and then for the Swiss bilinear is the way it's being rendered in. The other nulls here is basically just other manipulation techniques for the video, but we're not using that, so we're skipping that bit and keeping it at null. And yeah, I also forgot to mention this. The reason why this says if the SWS scalar context is not found, we set it up here. But if it's not found again, what we're doing is we're saying it can't initialize, and that's that. And then this next bit is basically having a... So the destination is the array. So this is basically where the frame is being made, and then this is the height, the width, and then all the data, what color the video is, or what color the pixel is, and then it'll assign. So in this case, it's assigning from left to right instead of going up and down, basically like the old CRT TVs. And then the very last thing that we'll be doing is we are closing the video, or we're closing the members themselves. So when the video rendering is done, it will close itself for a few reasons. The reason is if the GUI was still open, this would keep eating up. So if you were to render videos one after the other, it'll just eat up memory. What we're doing here is memory management, making sure everything is closed. And then we're going to go to the very top here. I'm going to show you guys the video render HPP. This is basically where all my headers are, where I'm calling the library from. It's because it's a lot simpler than calling it in each file, and everything's a bit more nice and neat. So in my video render state, this is the things I want for these are the variables I want to be usable in every file that I have. Excuse me. In this case, it's going to be video reader and main CPP. These are the variables themselves. And then these are the structures where if I want to call them, the variables that are stated in here will be called. And then to our final program, or to our final file here, what we're doing is, so let's go from the top. In this final file, what we're basically doing is we're calling the header studio, the GLFW, and the video reader HPP. The headers are the libraries that we're going to be using. They basically have the functions, so if we want to call them, we're able to use it. And then the video reader, whereas our custom functions are set in. So let's start. So GLFW initialize. So this will say if it can open the GLFW. This would only fail if it did not have OpenGL installed into the computer itself. The window is setting up for the size of the window for for GLFW. And then here in the video reader state, this is where we are opening the video itself. If I had the GUI ready to go, this would be replaced with file name, and then it'll be calling into the search bar from the GUI. This here is basically what renders the texture for GLFW, for the video render itself. And then here is where it basically allocates, or this basically says this is the height and this is the width. And then we'll have GLFW here. This is the GLFW time here is used for the timestamp, and the reason why I have this here is because I want this to be running in real-time playback for the video. And then this here is basically saying, okay, I've called it, now I want to make it. This is making the video itself, and then this is me making the height and width of the actual frame. And then in this bit, this is basically saying I can't read the frame. In this section, we're setting the time to 0. This is the start of the video. What I'm trying to do here is I want the video, when it's being played, to be as smoothly as possible. So it's making sure that the video is always up to date with, if you were to play the real-time video, if the video that we opened using our program is like lagging behind on frames, it'll try to catch back up. If the video is too slow and the processor is not able to catch up, it'll try to smooth that out as much as it can. So this is basically, these two basically work together. And then for this one, it's handling the textures themselves. And then this bit is basically saying the colors of the video, where they going to be. And then after that I close it and say, yeah, that finished working. So let me run the program again to show you what it looks like running. This is my video running here, and then these are the frames that was being mentioned earlier. So if I wanted to manipulate the data even more, I would be referencing these, and this would have been referenced for the audio if I had more time to do my project. This would be able to correlate the audio and the subtitles, making sure the frame is in key with the other frames for audio frame, video frame, and subtitles frame. Welcome back. Now it is time for the questions before I end this video. So the first question is, discuss the most difficult aspect of your project with particular emphasis on those areas related to your chosen specialization. The most difficult part of this project would have to be dealing with the documentation of FFmpeg itself. There's a lot of documentation you get from the developers themselves, but the problem is almost half of those functions are deprecated, meaning when I'm reading the documentation itself, I am not able to use that function because it has been removed, been replaced, and I have to look for something else. This becomes quite challenging to research since not a lot of information is given of a replacement for said deprecated function. To add more to that, when a function becomes deprecated after following previous documentation, almost all the code has to change since it changes what variables is given inside of it. Since it is also my first time coding in C, there is a hurdle for me of learning how to use the language itself. While some parts are similar to other languages I have done in the past, C can be quite challenging. C is able to control and access like the computer's memory and hardware to allow for a program to function. Since I am coding in C, I had to take into consideration about the problems I never had before. An example of this is the memory leakage. So I'm referring back to the packets earlier where I had to unref the packets because if I left them open, my memory usage would increasingly get higher as the video render, or not just the render itself, the whole project was running. It would be too much as it went on. Question 2. Discuss the most innovative aspect of your project. For example, with respect to your use of technologies, programming languages, frameworks, or security protocols, etc. If I were to fully complete this project, the most innovative part would be me allowing the user to have a video they wanted to have auto-generated subtitles for them, as this would be more convenient than creating an SRT file, which is the subtitles file itself, or manually placing the subtitles on top of their video. What this will do is FFmpeg will slice the data into streams. I will then get into Google's API audio transcription to make it into an SRT file. Once the file is completed, FFmpeg will take the SRT file and place it on top of the video. Once everything is done, this would have their own file and would be a place for them for exporting. Basically saying there's nothing right now that is like the project I was attempting to create, where there's a video, I want subtitles on top of it. There's nothing like that right now, and it was very challenging in that regard. And I think that because with my research being done online, I haven't seen anything like this being done so far. Yeah, so question 3. With respect to your requirement specification, what requirements have you since added, removed, or changed, and what impact had this on the completeness of your project? So, I have not removed nor added a requirement. I have the video file to be played in real time. This was basically something I added. That's not a requirement. The reason I added this was to teach myself how to use FFmpeg's library, where I would learn how to manipulate and create functions for myself. Unfortunately, this did set me back as I have not fully completed this project. As shown, I only have a video output without the... I only have the video output with video details and the command line detailing the frames itself. So describe in detail your approach to testing. So during the testing phase of my project, I tested the individual components, including video reader, the OpenGL renderer, and other modules to ensure their proper function and adherence to the expected behavior. I created the test case that covered different scenarios where I would be using different container formats. So for example, one of the most common container formats encoder is H.264. Encoder and container are very interchangeable because H.264 is what holds it, and then there's just other bits at the end that makes it as an MP4. And another video file I've tested myself is the MOV container and the AVI. These are different containers. I wanted my project to be able to use different... I want my project to be able to use different extensions from different video files. And basically after that... Okay, so and then we get into integration testing. So during the integration testing phase of my project, I systematically combine the individual components. In this case, the video reader and the video reader, OpenGL, to ensure that the integration was smooth, functioning with the program as much as I can, by making sure the components are passing the data from the video reader to the OpenGL renderer. I examined the data flow compatibility. This is where, at the beginning of my stage, my video was very laggy, in the sense where like it would be skipping frames and was not playing as smoothly as it was now. And then for the last bit, the end user testing. So during the user and testing phase of my project, I conducted the testing independently without looking for external help. I took the role of both the tester and the end user to make sure that the evaluation of what I wanted and what was so what I basically wanted was, I wanted to be comprehensive to the rubrics as much as I can, and from what I was reading online, what made a good GUI, I've done that to the best of my abilities for myself as well. So I improved the functionality for making it a bit clearer to read there. So back then I would have different... So my GUI would basically be everywhere and it wouldn't make much sense at all. I fixed it where it's nice, clean, and neat, and easy for the user to understand what's going on, even for someone who's not as used to using software as that. And then question 5. If you were to start your project again, would you change any of the decisions you made, for example, in relation to tools, technologies, languages, algorithms, security, testing strategies, etc.? So I would look for a replacement to FFmpeg, as it was a lot more complicated and not very friendly to developers using the library as I thought it would have been, because the documentation available online was quite old. The examples that I needed had a lot of deprecated functions. If like almost half of the functions I tried to use were deprecated, and I had to research more online where to or how to do it, how it was changed, and their change documents are very small in each update, so that was very hard to find. And then the most up-to-date example page I found for exporting the video was from 2011 to 2013. And yeah, but to continue the project, I'll continue to use FFmpeg because I've only started to understand, to understand FFmpeg itself. I would also say that I would also change the language if I had to start from the very beginning without prior knowledge. Just because C for me was a lot more, it was a lot more different to what I was expecting. And yeah. And thank you for watching. That's been it for me. My name is Lloyd Portez. That was the project of the Subtitleizer. I hope you enjoyed the video itself. Thank you for watching.